Yes, welcome to DC Economics. So today we are going to stick coherently looking on probability rules. So what you need to understand, there are main three probability rules that include addition rule, multiplication rule, and what is known as complementary rules. So we are going to begin with addition rule over here. What you need to understand in addition rule, for any event that are mutually exclusive, the probability of A union B is given by taking probability of A plus probability of B minus probability of A intersection B. The mutually exclusive is whereby there are events that tend to happen together simultaneously, whereby non-mutual exclusive, the events tend to occur to happen together simultaneously. Now let's consider an example. 180 students took examination in English and mathematics. Their results were as follows. Number of students passing English were 80. Number of students passing mathematics was 120. The number of students passed at least one subject was 144. Now, you're required to solve part 1, the probability that a random selected student passed English. Second, you're required to solve the probability that a random selected student passed mathematics. And third one, you're required to solve the probability that a random selected student passed at least one subject. And question number 4, you're required to find the probability that a random selected student passed both subjects. Now, solution. For that case, we consider to let out A, present out the number of students passed mathematics, and B, represent out those who passed English. So when we require to find out in part A the probability of a selected student passed English, so we take out the number of events over number of sample space. Number of events is given over there. The total students who passed English were 80, divided by total number of sample space, that is 180. So the probability will be equal to 4 over 9. Second, we're required to solve out the probability that a random selected student passed mathematics. So the probability that a random selected student passed mathematics is given by taking the number of observation over number of sample space, whereby number of events for the students who random selected passed mathematics were 120, divided by the total number of sample space, that is 180. So the probability of a random selected student passing mathematics is equal to 2 over 3. Part C, we're required to calculate the probability that a random selected student passed at least one subject. So the probability of random selected student passed at least subject is given by taking out the total number of students passed at least subject we are given to the data set of our scenario question above, that is 144. So we take out 144, that is we take out the probability of that is 144 divided by total number of sample space, that is 180. So the probability will be equals to 4 over 5. That is the probability of random selected student passed at least one subject. So let's come to part 4. We're required to calculate the probability that a random selected student passed both subjects. So we consider to take the probability of union. So the probability of union is the probability of mathematics union English. That is M represent out mathematics and E represent out English. So probability of M union E is equal to the probability of E, that is represent out English, plus probability of mathematics divided by minus probability of mathematics intersection E. So we need to consider what is the probability of E and what is the probability of mathematics. So the probability of E, that is probability of mathematics, is given by taking 80 divided by 180, that is equal to 4 over 9. And the probability of mathematics, as we did define earlier, we take out 120 divided by 180, that is equal to 2 over 3. So the probability of mathematics intersection E is given by taking out the probability of E times probability of mathematics. This will give out 4 over 5. This will be equals to taking out the probability of M intersection E. But the probability of N intersection E is given is equal to probability of all students who passed is equal to the probability of mathematics intersection E is given as taking out 4 over 5. It's like to say that for our scenario question above, for our scenario question is where we consider to take out the number of students who passed at least one subject, and then we divide by the total number of sample space, that is equal to 180. So we take out 144 divided by 180, that is equal to 2 over 3. So since we find the probability of M intersection E, let's plug it to our formula so as we can obtain the probability of random selected student passed both subjects. So it will be 4 over 9, that is the probability of E, plus probability of M, that is 2 over 3, minus probability of M intersection E, that is 2 over 3. That is equal to, that is equal to 4 over 9, not 2 over 3. That is equal to 4 over 5. 4 over 5. So when we plus 4 over 9 plus 2 over 3 minus 4 over 5, the answer will be equal to 0.31. So the probability of a random selected student passed both subjects, that is probability of M union E, is equal to 0.31. So that is how it is. Let's jump to another concept. So let's look on mutual exclusive. So mutual exclusive is a statistical term that is describing two or more events that cannot happen simultaneously. Let's consider an example. A card is drawn from a complete deck of playing cards. What is the probability that the card is a heart or an ace? So from this kind of scenario, we need to develop the data sets so as we can solve it. So let A to be the events of getting of an heart, and let B be the events of getting a tail. Yes. What you need to do here, actually we take out we find out the probability of A. So since the question requires to find the probability that the card is heart or an ace, so all represent out the union. So it's like to say we are required to find the probability of A union B, that is given by taking probability of A plus probability of B minus probability of A intersection B. So probability of A is equal to taking out the number of events over total number of sample space. But remember, the total number of cards we have is equal to 52 cards. Within the 52 cards, we have 13 cards which are sweets. But also we have another, we have almost 4 cards. We have other cards which are spades. That includes hearts or diamond and etc. So in order to find the probability of A will be the probability of taking those 13 sweets cards, that is the number of events, divided by the total number of cards, that is equal to 52. So that will be equal to 13 over 52. And probability of B is like to say we take out the cards which are spades, that is 4 divided by total number of cards, that is 52. So after finding that, let's now find what would be our probability of A intersection B, that is given by taking now probability of A times probability of B, that is equal to 4 over 52 times 15 over 52. That will give you 1 over 52. So after that, let's plug to our formula now to obtain the value. Probability of A union B will be equal to taking probability of A, that is equal to 13 over 52, then plus probability of B, that is 4 over 52, then minus probability of A intersection B, that is equal to 1 over 52. So the answer will be equals to probability of A union B will be equals to 4 over 13. So that is a probability that the card is hurt or unhurt. Let's come to another example. What is the probability of getting a total of 7 or 11 when a pair of dice are tossed? What is the probability of getting a total of 7 or 11 when a pair of dice are tossed? So solution. Let A represent out the event of getting a total of 7, and let B represent out the event of getting a total of 11. Now remember, there are two dice. So if there are two dice, the total number of sample will exactly give you 6 times 6. Since there are two dice, the total number of sample will be equals to 36. So what you need to remember, the pair of dice were tossed. So there was a probability of obtaining the two events at between. So let's find probability of A union B will be given by taking out probability of A plus probability of B. Remember, we have applied the union between two probabilities, that probability of A and B. This is because the question requires you have already observed the word or to the question. So probability of A union B is given by probability of A plus probability of B. So we take out probability of A, that is equal to the total number of outcomes I told you earlier are 36, since there are two dice that tossed. So when we find out probability of A, we take out the number of events of getting a total of 7, whereby we observe the total we'll observe to take out the probability of obtaining the outcome, that is 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. So when you take out 1 plus 6, you'll obtain 7. When you take out 2 plus 5, you'll obtain 7. So the same applies to other numbers. So we divide by total number of sample space, that is 36, total of cards between the two dice. So when you count out these figures that we have obtained, you'll obtain 6. So take out 6 divided by the total number of sample, that is 36. So the probability of A will be equals to 3 over 18. Now let's come to probability of B. So the probability of B is where now we consider to check out the events of getting a total of 11. So the event of getting a total of 11 is equal to 5 and 6 and 6, 5. So when we take out 5 plus 6 is equal to 11 and 6 plus 5 is equal to 11. So we never take above numbers numbers 11 or 6 or above the mentioned numbers over there. So when you divide out 2 divided by 36 is equal to 1 over 18. So the probability of B is equal to 1 over 18. So when we find out the probability of A union B, when you find out the probability of A union B, it will be equals to probability of A intersection B is equal to probability of 2 over 18, 1 times 12. That will give you probability of A intersection B is equal to 2 over 9. So that is how we solve the question. So the probability of getting, we can conclude now, the probability of getting a total of 7 or 11 is equal to 2 over 9. Normal probability does not exceed 1 to a given specific terms. Now let's jump to another concept. So this is the rule number 2, that is a multiplication rule. We have taken time to go through the addition rule. Now this is multiplication rule. So under multiplication rule, what you need to understand is that the probability of A intersection B is given by probability of A times probability of B over A. Now from this example here, our hand contains 20 red and 10 blue balls and are drawn from the bag one after another. So without replacement, what is the probability that the both balls are drawn already? Solution. Let A be the red ball and let B be the blue balls as observed. So we want to find out the probability that both balls are drawn already. Both balls are drawn already. Now remember, this urn contains 20 red and 10 blue balls. So the total number of balls is where you take 20 plus 10, that is equal to 30. But we want to find what the probability of A intersection B. Probability of A intersection B is given by taking the probability of B times probability of A given B. So this is the formula that we apply from this kind of scenario. Now we have let out A to be represent of the red balls and B to represent of the blue balls. So probability of getting a blue balls, probability of getting blue balls given by number. So the probability of B that is drawn of balls is given by number of events over number of sample space. Now remember, the total number of sample space is 20 plus 10, that is equal to 30. And the number of sample space is equal to 30. So the probability of B is given by taking out the probability of A with no withdrawn of balls is given by taking out probability of A, number of events that we take out, that will be equals to 20 divided by total number of sample space, that is equal to 2 over 3. For that case, probability of A with no drawn of the balls is equal to 20 divided by 30, that is equal to 2 over 3. Now after that, we take out the probability of A after drawn of the ball, that we consider to take out the two balls from the hand that is contained. We minus 1, since the probability that both balls are drawn are ready is where we remove 1 from the red ball. That is represented by A, that is will be equal to 19. And the number of sample space that is set to remove 1 ball, that is equal to 29. So when you find the probability of A after the draw of the balls will be equals to 19 divided by 29. That the probability of A that will, after the draw of the ball is equal to 19 over 29. Now we need to find the probability after the draw of the balls. That is the probability of B. Now from the second ball that's contained 10 of the blue balls, we remove 1. And the total number of sample space, remove 1. That will give you out 4 over 29. So when you remove 1, it will be 10 minus 1 is equal to 9. So 9 over 29, as you observe. So the probability of B after the drawn of the balls is equal to 9 over 29. Now, when we apply our formula, the probability of A given B is equal to probability of A intersection B divided by the probability of B. So probability of A times probability of B is given by taking out, is where now we consider to take out the probability of A, that is 19 over 29, and we times the probability of B, that is 9 over 29. So the answer will be equals to 19. The answer will be equals to 19 over 29. So we plug into a form of probability of A given B now would be equals to 19 over 29, as you can observe. So after finding the probability of A given B, now it is possible now to analyze from our equations. So let's find now the probability of A intersection B. So probability of A intersection B. So the probability of A intersection B is equal to probability of B times probability of A given B. So since we have the probability of B already, we consider to take out the probability of A, that is 19 over 29, will be equals to 19 over 29. I mean 4 over 20, since we have the probability of that is equal to 4 over 20. Then we times the probability of A given B, that is 19 over 29. So we take out, from our data sets, we take out 20, consider to take out, we take out 20 over 30. And then we times the probability of A given B, that is 19 over 20. So this will exactly give you exactly 38. over 37. That would be the answer. So it will give you 38 over 37. So let me lab over here so as I can demonstrate it properly. So probability of A intersection B is equal to 38 over 37, as you can observe. Let's check another example. Let's look on a complement rule. This is the last rule among the main rules of probability. So suppose if A and A complements are complements once, the probability of A is given by 1 minus probability of A complement. So for example, a coin is tossed 6 times in succession. A coin is tossed 6 times in succession. What is the probability that at least one head will occur? Solution. Now, from our formula, that probability of A is equal to 1 minus probability of A complement. Let A be representative of the head, that is, and B representative of the tail. So remember, when a coin is tossed, there is a possibility of obtaining either a head or a tail. But the formula regardless probability of A greater than 1 is equal to 1 minus probability of A, that is equal to 0. But remember, the outcome could occur since a coin is tossed. And remember, the coin is tossed 6 times. So the possibility of occurrence is given as a half for head and a half for tail. So we'll take out 1 minus a half, then you count a half times 6. Since the coin was tossed 6 times, so you minus a half times 6 times of the tossed coins. So this will give you, when you plug into the formula, this will give you, will give you 63 over 64. So that will be the probability, probability that at least one head will occur, as we observe. So we will consider the probability of at least one head occur is equal to 63 over 64. So that is the answer, and that's mark our hand. Thank you for watching. This is DC Economics. I beg you, let you subscribe my channel, hit the bell ringtone, as well as like for more favorable videos like this. Bye bye.